Good morning, all of you.
Good morning, sir.
Today we are going to just continue the things which we have already done. And last time you remember that we did certain topics on investments where we were very much particular about the return of financial assets and risk of financial assets. And we studied how we can evaluate a risk of an asset and a return of an asset. I think these two concepts are very, very important for a investment analyst, because investment analysts basically take their decisions on the basis of returns and risk of assets what they deal with. Therefore, it is very much important for you to understand the basics of evaluating the return of assets, particularly the financial assets, and the risk of it. Now, when you say risk, it is the risk of the return. What do you mean by risk of the return? Risk of the return is how the return varies, because you can't expect the same return throughout. For example, if you have a return at the end of a particular month as 10% for a particular asset, next month it would not be 10%. It would be either 12% or 8% or 5% or whatever. Such type of a variation can happen. Or in the third month, you might get a separate value for the return. Now, if you observe that during that period, for each month, you got a return, a variable return. Now, of course, if you do it any day, if you do it daily even, you will feel that the return you get would be different for each day. If you measure it for say a 6-hour period, that also will happen in the same manner. So therefore, when you talk in terms of risk, the meaning is your return varies. If your return varies, then that is the uncertainty. Because if you can just think about a certain asset and expect a certain return, if that return doesn't change, then there's no risk at all. Basically, if you get a say treasury bill or whatever, now treasury bill returns, if you get the coupon rate, so that coupon rate is a static amount, whereas the return of a treasury bill, even you can't say it's a constant amount. It changes because it changes in terms of the market value or whatever. So in the market value changes, the return changes. So therefore, you can't really expect any asset to have constant type of a return. But we have in our analysis, we might find such assets. Such assets are called risk-free assets. Risk-free assets. Basically, we identify these risk-free assets among the government securities. Right. Now, this is the normal discussion for these risk and return type of things. But our concern went into these evaluations. We evaluated the return at the beginning, and then we evaluated the risk of returns. Now, that risk of returns, we have a certain measurement device for that. That is the variance, but variance is the the particular square of a figure which we call the standard deviation. The standard deviation is the measure of risk. So if you want to get a particular asset's risk evaluated, what you need to do is you have to get the standard deviation of returns of that asset. If the standard deviation of returns of a certain asset is 0, that means it is a risk-free asset. It is a risk-free asset. And we did some calculations on the basis of historical figures at the beginning. Then we did calculations on expected basis. So that is what you call proactive type of calculations. And we did that analysis on the basis of probabilities. So we attribute certain probability to particular returns. And the total of probabilities come into 100% or 1. Then we have several alternatives of returns. And with that, we calculated the expected return. Now, when we calculate expected return, we base on certain probabilities of different alternatives. That's what we did last time. So expected return is calculated when we talk on futuristic situations. And when you get the expected return, and we call it ER or whatever, expected return, and we can get the variance of expected returns. Then after getting the variance of expected returns, by getting the square root of that, we can arrive at standard deviation of expected returns. So we did all that calculations. And later on, we went into another concept called covariance or covariance of returns. How the returns of two assets vary with each other. That is what you mean by covariance, or collectively vary. And we did the calculation for that also. That also we did on the basis of historical figures and on the basis of expected figures. So then we went into another very important value, which we call the correlation coefficient. There we talk in terms of correlation. That is also between two assets. And that correlation coefficient is calculated by dividing the covariance of returns of two assets by their standard deviations, respective standard deviations. For example, if you took assets A and B, so in order to get the correlation coefficient, you need to divide covariance AB by sigma A and sigma B, sigma A into sigma B. I think we did all these things. And there's a important point to note here. The correlation figure should be in the range of -1 and +1. It should lie between -1 and +1. -1 is the minimum value, +1 is the maximum value. So if you get a value which is less than -1 or higher than +1, then you have made a mistake. So therefore, you need to think that the correlation coefficient cannot be higher than 1 or less than -1. So these are the things which we learned last time. And there were some questions at the end of the lesson. And you need to just work out those questions first. I don't know whether you did it, and we also started something. Anyway, we will check those questions first. Right. Now I think you can see the lesson 1 on the screen. You see the lesson 1 on the screen?
Yes, sir.
Right, okay. So we will go to the questions at the end of the lesson. Right. Now, these are all supplementary problems because if you work it out, then you get complete understanding about subject. The Paracom Corporation, I don't know whether we did it last time. No, we didn't know. So it is for you. I mean, you need to do this at home and like self studies. The Paracom Corporation has the following probability distribution of expected future returns. Now, these are the probabilities. Now, if you need to look at this question first, what you need to do is you need to see whether it is correct. Because if you take these probabilities added up, okay, summed up, then it should be 1. Just look at and see whether it comes to 1. 0.15, that is 15, 10, 25, 45, 65, 80, 90, and 100. It comes to 100, so it's correct. So that is the way you can check it. Determine the expected return as standard deviation of returns for Paracom Corporation. So what are you going to do? Now here, since the percentages are given here, to make it simple, what you can do is when you do the calculations, you just omit this percentage mark. What you need to do is you can just see 0.15 into minus 50, 0.1 into minus 10, 0.2 into 5, again 0.2 into 12, 0.15 into 20, 0.1 into 25, 0.1 into 30. So then if you get the total of it, you get the expected return. Have you calculated that and you got an answer for that? Anyone who got an answer for that? Yes. $3.25. Yes, we will check. Anyway, maybe correct. So, any other answers you got for that? Yes. Right. So we will get that answer, and then again what we can do is we can go into the standard deviation. Now standard deviation is calculated by deducting the value you got from each returns. For example, now you have here 3.25. What we can do is you can deduct 3.25 from minus 15, and that has to be squared, and it has to multiply with 0.15. Then you get again 3.25, you deduct 3.25 from minus 10, and that has to be, so minus 10 minus 3.25 is minus 13.25. That can be squared and multiplied with 0.1. So that you can get, if you do the things for the whole data set, you will get the variance. And after that, you have to get the square root of that variance, and then you can arrive at standard deviation. That is how you can do it. I just assume that 3.25 is correct, right? Anyone who got some separate some answer, some other answer? $8.65. Right. Anyway, I will check. Maybe 8.65. Right. Now, anyone who got the standard deviation? Yes, 8.65 is correct. So, has anyone got the answer for the standard deviation? 14.67. Yes, yes. So the methodology is what you need to do is you need to deduct from each returns 8.65 and get it squared, then multiply with the probability. Okay, okay, okay. So we will go into the next one. Right, if you take the second question, the Maxim company had the following annual returns over the past 5 years. Now this is a simple one, so we need not just consume time on that. So you can get the average of it by getting all of the things added up and divide by 5, because there are 5 years taken into consideration. So then this can be totaled up and divided by 5, and then you get the answer. And standard deviation can be calculated by deducting from each return the average return, and you have to square it and get the total and divide it by 5 and get the square root. Then you get the standard deviation also. Right, the third one, because what I want to do is I want to just give you some understanding. If someone has difficulty in doing this, so I need to just advise them. That is why I just go through these questions again. An investor purchased common equity shares of a blue chip company at rupees 500 per share on 1st April 2019 and received a dividend of rupees 50 per share during the year. On 1st April 2020, he sold it at rupees 580. Now you can see the particular investment horizon is 1 year. So calculate the return grant gain from the investment for a period of 1 year. The price of the share dropped to rupees 400 per share on 1st April 2020. What would be the return on sale? So there are two things only, very simple thing. So here you can see he purchased at rupees 500, and that was on 1st of April 2019, and on 1st of April 2020 the share was sold at 580. So that means there's a capital gain of 80 rupees per share. And the dividends also he took, he got 50 rupee dividends. So then per share return is 80 plus 50, that is 130. 130 divided by 500. So that could be the return. 130 divided by 500. And that as a percentage is 26%. So I think that's the return for that common equity shares which the investor purchased. So yes. So next thing is if you look at it, then there's another alternative given, and the share, instead of rising it to 580, it has come down to 400. So that means there's a drop in value, 100 rupees. 100 rupee drop in value, say minus 100. Then you have a dividend of 50 rupees. So dividend of 50 rupees minus 100 means minus 50. Minus 50 over 500 is, that is 10%. Minus 10% is the return at that situation. So the situation where the share price has dropped to 400 rupees. Now here, these things. But I don't think that we need to, I don't know whether you need to do it with you. I mean, can you do it on your own? So we can go to the next lesson if you are comfortable with doing these things. Or even I can work it out if you want. What do you say? What do you say? I mean, shall I do it, or you can?
Yes, sir, you can.
I can do it, or I can omit it.
Yeah, we
Do
can
it.
do
Do
it.
it. Do it. Okay. 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 I will do it. Right. Right. Then I will just work it on the board. Now, first of all, you need to just tabulate a certain thing where type of a schedule like. Now you can see here there are 5 different status of the economy. Those status are boom, recession, normal, recovery, and slow growth. These are the different state of the economy. Now, in the problem they have given, they have attributed different probabilities for each of these states of the economy. For boom state, they attributed the probability of 0.1. For recession, they attributed a probability of 0.2. For normal, they assigned a probability of 0.4. For recovery, they assigned a probability of 0.1. And for slow growth, they assigned a probability of 0.2. Now, I will ask a question. Now, what is the most possible economic state or state of economy? By looking at it, you can give an answer. What is the most possible economic state of economy? What is the most possible one?
Normal.
Yeah, normal one is the most possible one. Yes, it is understood. So anyway, then the returns are given for Jones, that is one type of a company, and the other company is Sun Corporations. Now this Jones Corporation will have a expected return of 14% at the boom state, and minus 5% at the recession state, 10% at the normal state, and 9% at the recovery state, and the 12% at the slow growth state. So for the company, the corporation Sun, there they will have 20% in the boom situation, and -2 in the recession, and 9% in the normal, and recovery state 14%, and slow growth they will get 18%. So first of all, what we need to do is we need to determine the expected covariance of returns for the Jones and Son Corporation. Now, you need to see how you can tabulate the things. So that is the most important thing. So even sometimes people, if you know how to handle it, you can do it through the Excel also. But even if you don't have any idea about Excel, you can do it by having a worksheet. So that worksheet has to be designed in a certain manner where you can get the things clearly. So then you can just tabulate the worksheet. So I will do it on the board. Right. Now you just look at the table. I don't know whether it is very clear. So starting from here, this is the probability column, 0.1, 0.2, 0.4, 0.1, 0.2. Then this is the return column for J, 14, minus 5, 10, 9, and 12. This is the return column for Sun, that is 20, minus 2, 9, 14, and 18. Then what you need to do is the fourth column. It should be the multiplication of column 1 and column 2. So that you can get these values from that. And column 5 is the multiplication of column 1 and column 3. So I think that is the first part of it. So I don't know whether you got the correct answers for mu J or the expected value of J and expected value of S. Yes. Have you got the expected value of J and expected value of S? Now this is the way it can be calculated. And the same type of example is worked out in the lesson. So you can just see that also. Here. Now in this case, the expected values were calculated separately, and it has been just inserted here. Here also we can do the same thing, but I have just entered all these things into the schedule. Just see. Now either you can do this separately, or expected values can be calculated in a separate place, and then those values can be taken here. So that is another way of doing it. But in this schedule, I just worked it out on the board. So I think now this is the way it can be worked out as on a table. Yeah.
එක වැඩි කිරීම 14 වුණාම 1යි දශම 4 නෙමෙයි සර් එන්නේ.
Yeah. That is, yeah. Point 1 into 14. 0.1 into 14, that is 1.4. Point 1 into 14 is 1.4. 0.2 into minus 5 is minus 1. 0.4 into 10 is 4. 0.1 into 9 is 0.9. 0.2 into 12 is 2.4. Right. Now, that is how the thing's been done. Anyway, now here I calculated the expected value of J. It is 7.7%, and expected value of S is 10.2. 10.2. Now then we can use these values to fill the other columns. Now, for example, you have this column that is Rj minus mu j, that is return is 14, 14 minus 7.7. 14 minus 7.7, it should come here. Then here it should come minus 5 minus 7.7. 10 minus 7.7, 9 minus 7.7, 12 minus 7.7. That values should come here. Then here another set. There you get 20. 20 minus 10.2, minus 2 minus 10.2, 9 minus 10.2, 14 minus 10.2, 18 minus 10.2. That should come here. So then we need to get the multiplication of these two. Then we can calculate the covariance. That is how it is calculated. So, yeah. Yeah, Chaturanga, your answer is that is you got expected value of J, J's return, that is 7.7. Expected value of the other corporation, that is Sun's return, is 10.2. That is correct. Now, when you got this, what we need to do is we need to fill up the other columns by using these values. So the column that is, I just put it as column number 4, sorry, column number 6. Column number 6. 1, 2, 3, 4, 5, 6. Column number 6. Column number 6. Right? Column number 6, how are we going to get the column number 6? That is this return, 14 minus 7.7. 14 minus 7.7 is 6.3. 6.3. Minus 5 minus 7.7 is 12.7. Minus 12.7. Then 10 minus 7.7 is 2.3. 9 minus 7.7 is 1.3. 12 minus 7.7 is 4.3. Right? Then you get the column number 7. Column number 7 you can arrive by deducting from this column, the column number 3, the value of expected value of Sun. That is 10.2. So you need to deduct 10.2 from 20. That is, you get 9.8. 9.8. Minus 2 minus 10.2 is minus 12.2. 9 minus 10.2 is minus 1.2. 14 minus 10.2 is 3.8. 18 minus 10.2 is 7.8. Right. Now you got the values for the columns 6 and 7. Then column 8 is the multiplication of column 6 and column 7. So you can get those values also. 6.3 into 9.8. 61.74. 12.7 into 12.2. 154.94. Then you get 2.3 into minus 1.2. 2.3 into 1.2 minus 2.76. Then you get 1.3 into 3.8. 4.94. And you get 4.3 into 7.8. 33.54. Now you can take the sigma or the total of this. That is 61.74 plus 154.94 plus 4.94 plus 33.54 minus 2.76. 252.4. Now this is the covariance. Covariance is equal to 252.4. This is the covariance, right? Then we need to get the values, column number 9 and column number 10. The values will be the squares of column number 6 and column number 7. You have to get the squares of those values. I will put those values also. .3 square. 39.69. 12.7 square. 161.29. Then 2.3 square. 5.29. Then you get 1.3 square. 1.69. And you get 4.3 square. 18.4. Then the column number 10, that is the square of column number 7. 9.8 square. 96.04. And 12.2 square. 148.84. Then 1.2 square. 1.44. Then 3.8 square. 14.44. Then 7.8 square. 60.84. Now we can get the total of these values, these columns. Column number 9 total. That is the, sorry. So then we need to have another 2 columns. You need to multiply these things with, this has to be multiplied with the probability. Anyway, the covariance.
So excuse me,
Yeah.
can't see the screen. Can you take that column into the left side?
The cornermost one, no?
Ah, yes, sir.
This one.
The number
Right.
11?
Right. Okay, okay. Is it okay to put it here?
Sure, sir, sure.
Right. Okay. So then column number 11 I will take here. 11. $12 and $30. $11 will be the multiplication of column number 1, 6 and 7. 1, 6, 7. Now this is how the column number 11 can be created. Probability into Rj minus mu j into Rs minus mu j. So that is what we need to do here. So I will get the values there. Point 1 into, yeah.
Can't see the screen.
And
Can't see the screen, sir.
this side you cannot see this one.
No, sir.
So you can, I think are you in the phone or?
In the phone,
We
sir.
can see it, sir. We can see it clearly.
Yeah, we can see, sir.
You can, no? Right. So of course the phone can be zoomed or whatever. So I don't know whether you can get it through a phone, but normally you can get it from the normal screen of a laptop. Can you see these things?
Yes, sir. Then now.
Right. Is that okay? Right. Okay. So I will just work out here. I think most of the people see these things. Is that okay? Can you see this side?
Yes, sir.
Yeah.
Okay. Right. So there you get the column number 11 can be created through multiplication of the column number 1, 6 and 7. So that is 0.1 into 6.3 into 9.8. There you get the value 6.174. And
We can get column number 1 and 8 now, sir.
Column number 1 and 8 also. Yeah, that is okay. Yes. No, I just want to show you the way it has come. Anyway, that also can be done. Column number 1 into 8. Yes, correct. 1 into 8. 0.2 into 154.94. That is 30.988. Then you get 0.4 into minus 2.76. That is minus 1.104. Then you get 0.1 into into 4.94. 0.494. Then you get 0.2 into 33.54. 0.2 into 33.54. That is 6.708. 6.708. Now these are the values we got for the column number 11. I will repeat. 6.174, 30.988, minus 1.104, 0.494, 6.708. Now the total of which can be taken as the covariance. So that is 6.174 plus 30.988 plus 0.494 plus 6.708 minus 1.104. That comes to 43.26. 43.26. That is the total of column number 11. I think you all got it. So column number 12 is the multiplication of 1 and column 9. And column number 13 is multiplication of 1 and column 8 here. 1 and column 8 in 1 and column 9. One into column 9 and 1 into column 10. Again, I will. 12, column number 12, we can take by multiplication of column number 1 and column number 9. Then column number 13 can be populated by multiplying column number 1 with column number 10. Right, we will do the column number 12, 0.1 into 39.69. 3.969. Then you get 0.2 into 161.29. That is 32.258. Then 0.4 into 5.29. 2.116. Then 0.1 into 1.69. That is 0.169. And the last one, that is 0.2 into 18.49. 0.2 into 18.49. That is 3.698. Now we can see what is the total here. 3.969 plus 32.258 plus 2.116 plus 0.169 plus 3.698. That is 42.21. Then we take the 13 column number 13, that is the multiplication of column number 1 and column number 10. That is 0.1 into 96.04, 0.1 into 96.04, that is 9.604. Then the second value 0.2 into 161.29. Sorry. 0.2 into 148.84. 0.2 into 148.84. That is 29.768. And you get 0.4 into 1.44. That is 0.57x, 576. Then you get 0.1 into 14.44. 0.1 into 14.44. That is 1.444. Then you get 0.2 into 60.84. That is 12.168. Right, now we get the total of it. 9.604 plus 29.768 plus 0.576 plus 1.444 plus 12.168. 53.56. Right. Now we got the values now. Of course, the covariance is 42.21. Then we can say variance A is equal to square root of 42.21. 42.21 square root. That is 6.496. 6.496. Variance S is square root of 53.56. That is 7.318. Right, now these are the values. Or in other words, these are not variance. This is the sigma. Variance we have taken, this sigma. Sigma J and sigma S. Sigma J and sigma S.
Sir, covariance is 43.26, right?
43.26. Now these values are okay.
Yes, sir.
Then the addition.
Sir, covariance is the 11th column, right?
Yeah. Right. Okay. I made a mistake there. Right. Thank you. Now that 43.26 the covariance. Yes. Correct. 43.26. Okay. Now other values. Now this is the variance of J. Variance of J 42.21, and we have to get the sigma or the standard deviation by getting the square root of that. The square root of 42.21 is 6.496. Then the square root of 53.56 is 7.318. Now we have come to the required values, because now of course we can get the expected values also. Now we have already done it. That we did at the beginning. This is the expected value of J, that is 7.7. I can put that also. EJ is 7.7. All these are in percentages. ES is 10.2. These are the set of values we found. Now, as per the question, we need to calculate the correlation coefficient. The correlation coefficient is to be calculated. Now, how are we going to do that? Now, we have now got all the values which are necessary to calculate the correlation coefficient. So, correlation coefficient is given by an equation. So, the correlation coefficient we normally denote by rho. Rho, now in this particular case, rho Js is equal to covariance Js divided by sigma J sigma S. That is how we can arrive at correlation coefficient. So I will put that here. Rho Sj or Js, whatever it is, okay. Js or Sj, whatever it is, there's no difference. You can say Js or Sj. Since we first took the J here, so we can put J as Js. Rho J is equal to covariance Js divided by sigma J into sigma S. This is how the correlation coefficient is calculated. So covariance Js we have calculated, that is 43.26 divided by sigma J we calculated 6.496 into, then we calculated sigma S also 7.318. Right, now we do the calculation and see what is the value here. $43.26 divided by 6.496 into 7.318. 0.91. Got the value 0.91. This is the correlation coefficient. Now, you can have a preliminary check here. What is the preliminary check? Now, just look at the value you got for correlation coefficient, that is 0.91. Is it a reasonable value? Yes, because it really lies between -1 and +1. The 0.9 is very close to +1. 0.91 here. It's very close to 1. Very close to 1. Okay. Right. I think I think you have already followed this and you got it cleared now. You can have your own way of doing, and you can just prepare one where it is more simple than this even, so that you can think and do it. Now we will see the question and try to answer the question. Now make sure that even though this is a laborious task, your attention should go into the analysis part. This is a laborious thing, then you have to do that. And it's a time-consuming affair. But anyway, your main attention has to be given to the analysis part. So therefore, the numbers, you have to just fabricate a story based on these numbers. That is what we need to do. So I think that is the most important thing for decision makers. That is very important. The numbers, you need to do the calculation. That is a different case, but the calculations alone will not help you. So you have to get the calculations, you have to get the values, you have to get the evaluation and whatever. But then the most important part is the evaluation and the decision making part. Right. We will see how we can arrive at that part by looking at the question. Right, as per the question, we will go to the question and see what it asks. Right, determine the expected covariance of returns for the Jones and Son Corporation, and we have already done it. And that is how much? As you said, yes, 43.26 is the answer for that. The part A answer is 43.26. Then the part B, what is the correlation of returns between the Jones and Son Corporation? Correlation of returns. Yeah, correlation is the correlation coefficient we are talking about. So that is rho JS. Rho JS is equal to, I just put the equation there. It is equal to covariance Js divided by sigma J sigma S. And that comes to the value 0.91. Then the third part is the most important part here. What is your opinion about the above relationship? So can you just give your opinion in one sentence? Now, we have done all these laborious things in order to arrive at an opinion, right? So come up with your opinion now.
There is a strong positive relationship between
Yeah,
the
there's a
assets.
strong positive relationship. It is, you can say in percentage terms also you can say. So you can say it is 91% related, 91% positive relationship. So you can say it's a very positive relationship is there. So the meaning is, if the returns of Jones been going up, returns of S also will go up in the same level, or 91% of that level. So that is what it means. So then the relationship is a strong positive relationship, you can say. Now you can here you can say it is strong, because now normally there's a particular benchmark here. If you have a relationship which is less than 50%, we call it an insignificant relationship. If it is more than 50% only, we call it a significant relationship. But if it is more than 75, we can say it's a great or strong relationship. If it is close to 90 or higher than 90, then we call it a strong, very strong positive relationship, you can say. And you can say if it is 1 or 100%, you can say it is a 100% positive relationship. That is how you can analyze the value of correlation, right? So physically, what is the meaning? physically what is the meaning. We have to get the physical meanings also, because otherwise it doesn't make any sense. Therefore, you need to get the physical meaning also. Now you can just see the covariance also, it has become a positive figure, and therefore the correlation coefficient also becomes positive. Now if you get a value minus for covariance, invariably you get a minus value for the correlation also. Then I am just asking a question. What is the difference between covariance and correlation coefficient? I think on the face of it, you might see that both talks on the same thing. Both talk on the same thing. Is that so? Or you have any type of a difference between covariance and correlation coefficient? Yes, what is your point of view? Now, this type of opinions are very important. Yes. Anything you can put forward? I really eager to have your opinion on that. What is the real difference? Actually, I can remember someone has asked that question even last time. Anyway, I want to check whether you remember that. Yeah. Yeah. What do you think? No, I'm just asking you, because it's very much good for your say the conceptual thinking. Now, Geethanjana said it's a positive relation. That's okay. But what I'm asking is, you have to differentiate what is the covariance and the correlation coefficient. What is the real difference? Or there's no difference at all? What do you say?
Correlation measures the strength of the relationships.
Yeah.
While covariance measures the direction of the relationship. That means
yeah, it's rather, you have given it in, yeah, I think your answer is fair enough, but I think it has to be little quantifiable. So that quantification is the most important thing here. Now, when you get the covariance, now you get it in terms of generalized relationships, but when you get the coefficient calculated, we call it a normalized calculation, where you divide it through by the standard deviations. So therefore, as you say, it's a direct quantification, or even we can say it's a real percentage. The percentage shows the strength of the relationship. Or in other words, if the percentage is low, the relationship is low or weak. If the percentage is higher, the relationship is more stronger. So that is the indication given by the correlation coefficient. But if you go into the covariance, it doesn't give a certain type of quantification. It just, as you say, it just gave the direction only. Just gave the direction only. Because the normalized type of quantification is given through the correlation coefficient. I think I can accept your answer. I can accept your answer. So you can elaborate that the quantification is in the form of a percentage, and that percentage, the strength or the value of the percentage is or in other words, the value of the percentage says the strength of the relationship. Right, that is the answer. Okay, correct. Right, now we will go to the lesson 2. I think you can see the things on the screen. Now today we are going to discuss about portfolio theory and related topics. So that's why I just worked out that sum on the board, because even some people have some reluctance on entering into this type of calculations. I just wanted to put you into that field, because you would be in a position to do that without any resistance or whatever. So I think doing this will help you to get into the real field, because don't just look at it and just keep quiet. You just do it yourself. That is the way you can enter into this. Even some people have some reluctance in joining this type of things, but I really advise them to, even with the reluctance, you just join, and then you will see the real worth of it at a later stage. Right. Now, though we talked in terms of individual assets at the beginning, in an environment, a real-time environment, what happens is, even in organizations, you find portfolios of assets. For assets, you get number of assets in one portfolio, and we deal with that portfolio as one or unique. Say housing loan portfolio. Yeah, you have several assets in the portfolio. So then, now we learned characteristics of individual assets, where we went through the returns of assets and the risk of returns and all that. But our real-time or real-life scenarios, mostly with set of assets, portfolios of assets. So therefore, we need to deal with more or less with all of the time portfolios. So then we have to see the portfolio behavior, how the portfolios behave in terms of the included individual assets, returns and risk. So that is our lesson today. So we can start with the return of a portfolio of two assets, because that is the most simple type of a thing, where only two assets are in the portfolio. But many more times you will get more than two assets in most of the portfolios. Or for that reason, you can say it's about 50 to 100 most of the time. So it is very important for you to understand, when you know the returns and risk of individual assets, how are we going to get the portfolio view of that? How are we going to arrive at the portfolio return and portfolio risk of return? Right. So we can start with the return of a portfolio of two assets. Then we will go to the return of a portfolio of n assets. N means n can be any number. So then you will be in a position to arrive at the whatever the portfolio, whatever the number of assets in the portfolio, you will be in a position to evaluate the return of that portfolio. So then we go to the third one, is the risk of a portfolio of two assets. There also, portfolio is taken, a very simple portfolio where only two assets are there. So we learn that first. Then we learn how to do it for a n asset portfolio. Then we go to another concept called concept of efficient frontiers, and we call in some quarters we call it Markowitz portfolio theory. Then formation of an optimum portfolio, different explanations on capital market line, and understanding the capital market theory. So these are the things which we are going to discuss on today's lesson. Right. I think the simple thing we can do first, assume that asset A and asset B form a portfolio P with a weight of W1 and W2. What do you mean by weight? So to form a portfolio, you have to get the mix of A and B. So we can mix it in different form. So you can have 20% of A and 80% of B. You might have 30% of A and 70% of B. You might have 50% of A and 50% of B. Likewise, you can have different weights. So those weights, we assume that the weight of A is W1, weight of B is W2, where W1 plus W2 is equal to 1. So then, how are we going to get the return of portfolio? So that portfolio return comes with the valuation W1 into R1 plus W2 into R2. That gives the return of the portfolio with only two assets. It's so simple. Now, since it is so simple, we will go to the n asset situation also. A portfolio with assets 1, 2, 3 up to n generate R1, R2, R3. Now these things are clear enough because in mathematics we normally symbolize these things in this manner. So asset number 1 have a return of R1. Asset number 2 will have a return of R2. Asset number 3 will have a return of R3. Asset number n will have a return of Rn. And the respective weights are also given, W1, W2, and weight of asset 1 is W1, weight of asset 2 is W2, weight of asset 3 is W3, and weight of asset n is Wn. So there, the same conditions are being fulfilled, where W1 plus W2 plus W3 plus Wn is equal to 1. And there the R, or the portfolio return, is given by W1 R1 plus W2 R2 plus W3 R3 up to Wn Rn. So we will have to multiply the weight with respective return and get the total of all these assets, and you will get the portfolio return. I think this is simple enough. Then we can have a numerical example. Right. I will give you a numerical example where you can work it out. So company A has a return of, so I will put it on the board. Is it okay to wipe off the board, or I should retain it? Should I retain it, or?
You can wipe it.
Right. Right, I just put a small exercise, so you can just look at it. Right, you can just look at the shares of company A and company B recorded annual returns of 20% and 30% respectively. If you have a portfolio with 40% of A and 60% of B, what is the portfolio return? So that's a simple exercise, you do it. There's a portfolio with shares of A and shares of B. Shares of A has a return of shares of B or shares of A has a return of 20% and shares of B has a return of 30%. And the portfolio is a mix of A, 40% of A and 60% of B. What is the return? Portfolio return. So that is the question. What is the portfolio return? Yes, what is the answer? Simple one, very simple one. Now here the weights are given. Weight of A is 40 and weight of B is 60, sorry. Then get at the portfolio return. What is the portfolio return? This is a simple one, very simple one. Annaratna, it's okay, right? Dakshina, I think you made a small mistake, I think. Just make it correct. I think you have some issue with the decimal. Misansala is correct. Yes, it is simple. What we need to do is, we need to get the return and multiply it with the respective weight. Now here, company A has a return of 20 and the weight is 40%. So therefore, you get 20% into 40%. 20% into 40%, that is 0.2 into 0.4. That is 0.08 plus. You have another company, that is company B. Then it is 30% the return and the weight is 60%. So 0.3 into 0.6, that is 1.8. Sorry, 0.18. Sorry, 0.18. 0.18. 0.18 plus 0.08, that comes to 0.26. In other words, it is 26%. Right. I think you all feel that it is not a big task. It is very simple thing here. So we will go to the lesson again. Now, my intention is to put you into a very practical form where you don't have any burden of memorizing or whatever. If you really learn these basics, it is very easy for you to do the analysis and all. That is why I just try my best to put you into a working state. Right. When you have n assets, what will happen? So I will just now another exercise I will give for say 5 assets. 5 assets. So then also you need to you will be in a position to calculate it. But anyway, for the time being, I will just omit that exercise. Anyway, I will go to the next topic, that is the risk of a portfolio of 2 assets. Now we are now trying to get the risk of it. Now we have already done the calculation of return of a portfolio. Now we will go to the calculation of a risk of portfolio with 2 assets. Now, in order to calculate the portfolio risk of return, we need to have the risk and returns of assets in the portfolio. In our first case, it is only 2 assets, so therefore we need to know. We have taken it as asset A and asset B, and asset A's risk and asset B's risk, and asset A's returns and return. Asset A's risk and only the risk we need to know, and not only that, we need to know the covariance between these 2 assets. Right. Now, for that, we have come up, or we have arrived at a certain formula. Now that formula is an innovation or invention of portfolio theory, and the inventor was basically Alfred Markowitz. And this is the equation where we can calculate the risk of a portfolio with 2 assets. Now I will explain these letters. Now here it is given as sigma p squared, that is the portfolio risk. We get the square. It is equal to W1 squared into sigma 1 squared. W1 is the weight. Weight squared into sigma 1 is the risk of the asset. Asset number 1 or asset A. Sigma 1 squared plus W2 squared into sigma 2 squared plus 2W1 W2 into covariance 1 2. So this is the equation. Now I will give you a guide in order to memorize this form or this formula. Can you remember there was a algebraic expression? I think you studied it in your basic, very possibly in standard 7 or 8. Can you remember that? A plus B squared. A plus B squared. Now, when you want to calculate A plus B squared, what you do? A plus B into A plus B. So the result would be A squared plus 2AB plus B squared. I will show it on the board. I will show it on the board, and then you don't feel like very burdensome to memorize these things. So therefore I will just show you how are we going to memorize those things. No issue at all. A plus B squared equal to A squared plus 2ab plus b squared. Now this is a algebraic expression you studied in your standard 7 or 8. I think you can just recollect it. Now just look at it and see what is the similarity of this portfolio risk formula. Now here you can see two square figures. A squared is one, B squared is the other one. So what we can do is we can rearrange it. A squared plus B squared plus 2ab. Right? Now here what we are going to do is sigma p squared is equal to, now the sigma p is constituted through sigma, so we put it the asset A's risk as sigma 1, asset B's risk as sigma 2. So we go by sigma 1 and sigma 2. So there sigma p squared is equal to W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus 2, the same way, 2. Here you should get covariance 1, 2. This is the answer. Now you see the similarity of these two. Because when you get the two things together, you get the covariance. I think now you will be in a position to memorize these things without much issues. Right, now we will go to the formula again. Now I just got the formula this way. Sorry, there's a mistake. W1, W2 should come here. 2 W1, W2 covariance 1, 2. So this is the formula. Right. Now we don't need sigma b squared. Sigma b squared is the variance, but we need the standard deviation. So therefore we get the square root. Now we had another equation already. We went through another one already. This is the equation that we learned last time. That is the correlation coefficient between 1 and 2 is equal to covariance 1, 2 divided by sigma 1, sigma 2. So then we can replace covariance by cross multiplying this equation. Now say covariance 1, 2 is equal to rho 1, 2 into sigma 1, sigma 2. Now what we are going to do is we just substitute covariance 1, 2 with this value, rho 1, 2, sigma 1, sigma 2. So after doing that substitution, you will get this formula. Now the covariance doesn't come here. Instead of covariance, we put it sigma 1, sigma 2 into rho 1, 2. If the covariance is given, without taking sigma 1, sigma 2, rho 1, 2, we can just put covariance there. In the portfolio risk or the standard deviation is given by sigma b, which is equal to the value of the square root of the right hand side total. Okay. Okay, now shall we do a simple exercise on this? We will say, we will go into the exercise we did at the beginning today. There we arrived at covariance figures and sigma figures. So as per the sigmas, we had correlation coefficient we got as 0.91, is it? Yes, 0.91. No, covariance is also there. Covariance also we calculated. That is how much? We got it as 53 point something. No. Yeah, what was the covariance we got? Right.
43.2.
Yeah, the calculated covariance was what for what our exercise today? 53 point something. No, is it
43.26.
53.26?
43.
43.26. Yes, 43.26. So that was the covariance. So can we assume for that particular exercise the weights, right? So now I will put it as an exercise now. Wait, I will just hit it again. Anyway, no, I will just give a fresh one. Right. Now, just look at it. In a portfolio, there are two assets, A and B. The covariance is 33. The covariance is 33, and the sigma A and sigma B are 20% and 30% respectively. So standard deviation of A and standard deviation of B are 20% and 30% respectively. If the portfolio weight of asset A is 20%, what is the portfolio risk? That is the question. I think all the data is available. So you are in a position to now calculate the portfolio risk. Asset A's risk is given, asset B's risk is given, and asset A's weight is also given, and the covariance given. Right, work it out. Yes. If you use a calculator, you can just at one go you can do it. If you use a scientific calculator. Yes. Yes. Now you have been now it is given in the sum. The risk, asset A's risk is 20%, and asset B's risk is 30%. Weights are also given. Asset A's weight is 20%. So therefore, what is the weight of asset B? 80%, yes.
80%.
80%, yes. So now what are we going to do? Try to do it. Now, first of all, you need to take, and in the formula is W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus 2 W1 W2 covariance 1 2. So I will do it for you. W1, the weight, that is 20%. 0.2 squared into what is the risk of A, that is 20%. 0.2 squared into again 0.2 squared plus, then you have what is the weight of the second one, that is B, that is 80%, so it is 0.8 squared into what is the risk of that, 0.3 squared plus 2 into 0.2 into 0.8 into covariance. What is the covariance? 33 equals, yes, you get a value 10.6192, that is the square or the variance of the portfolio. Now, in order to get the standard deviation, you should get square root of that. That comes as 3.258. The answer is 3.258. 3.258 is the answer. Now, I am not asking for the return. No? Not the portfolio return I am asking. I am asking the portfolio risk, not the return. Right. You can work it on. I will just give you a break and we'll come back by 10:45. Yes, I will. I will just do it on the board after the break. Right. Ms. Ansala's answer is correct, but I will just do it on the board. Right. Now, first of all, what we need to do is we need to just jot down the data. Now, as per the data, A, B, sigma is 20 and 30. Weight is 20 and 80. Covariance is 33. Now these are the data. Instead of AB, we put 1 and 2. So therefore, then we have to write the formula. Sigma p squared is equal to W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus 2 W1 W2 covariance 1 2. Now the A is 1, B is 2, right? So now we just substitute the values here. W1 is 20, so 0.2 squared into sigma 1 is 20, again 0.2 squared plus W2 is 80. 0.8 squared into sigma 2 is 30, so 0.3 squared plus 2 into 0.2 into 0.8 into covariance 1 2. The covariance 1 2 is 33. Now this is the expression. So you have to simplify. When you simplify, 0.2 squared into 0.2 squared, that is equal to 0.0 0.016. So 0.0016. Oh, I can just take the whole thing without putting individual ones. So I will just do the calculation directly, the whole thing. Now what we need to do is 0.2 squared into 0.2 squared plus 0.8 squared into 0.3 squared plus 2 into 0.2 into 0.8 into 33. So that comes to 10.6192. That is the variance. 10.6192. 10.6192 is sigma p squared. Then sigma p is equal to the square root of 10.6192. So we get the square root. .258. That is as a percentage. That is the standard deviation of the portfolio. Right. I think now it's okay. Right. Now, you had any difficulties in the calculations? I don't think so. It is simple, but if you use a calculator, you can, that you don't need to face difficulty so much. Yeah. Ms. Ansala's answer is correct. Right. Okay. Oh, now at the same time, what you can do is you can just calculate the portfolio return also. That's very simple. You calculate the portfolio return also. I have not given the return figures, no. Anyway, I will give the return figures also. Now you getting the return figures as this. You get the portfolio return also. Because you have a return of 40% from A, asset number 1, and 30% of return from asset number B. So you need to calculate the portfolio return. Just calculate the portfolio return also. Yes. Yes, come up with the portfolio return. Yes, come up with the return, portfolio return. Yes, Kanwaratna's answer is correct. Chamali, just look at again. Look at it again. It's so simple. So return is 40%, weight is 20, so 0.4 into 0.2, that is 0.08, plus 0.3 into 0.8, that is 0.24. 0.24 plus 0.08 is 0.32, that is 32%. Yes, correct. All are correct now. Anyway, now our attention goes to the portfolio's risk and the return. We will just tabulate it. Risk, return. We can say portfolio 1. Risk is 3.258. Return is 32%. This is the portfolio. Now, we can just get those things by changing the weights. Now, this particular result we got through the weights. Asset number 1 is 20% and asset number 2 is 80%. Now we can just look at it again by changing the composition of assets in the portfolio. So you can go for another alternative. that is, we can say the portfolio 2, there the asset combination is, you can say 30% of A and 70% of B. Just calculate the risk and return for that. So there you have 30% of A and 70% of B. 30% of A and 70% of B. Here you get 20, 80. So then you have portfolio 2, 30, 70. I do the calculation and see what it is. All others remain unchanged. All other values remain unchanged. You just change the weight only. Weight to be changed to from 20 to 80. Now you have to change it to 30 and 70. Just do the calculation quickly. First, you need to calculate the risk, then the return. And the easier is the calculation of return. Yes. Now do the calculation with these new weights. Gitanjana, just check it again. Now I will just tell you the figures again. Now this time the weight would be A is 30%, B is 70%. That is the only change. Others remain unchanged. Because here the change is only the weights, 0.3 and 0.7. Yes, return portfolio return is correct. Deshan's answer is correct. Return 33. Yes. Yes, Miniruan's answer is correct. The portfolio risk is 3.729. Yes. 3.7293. That is correct. Rohan correct. Udeshan correct. Udeshan is given, he has given the return. That is 33. Correct. So then I will put the values for portfolio 2. That is return is 33%. Risk is 3.729. So we can have another portfolio, that portfolio 3. Now it has a 40% of A and 60% of B. Just do that also. Now I have added another one, a portfolio called portfolio 3. That is A has a weight of 40% and B has a weight of 60%. So that also you need to calculate. First you calculate the return for the portfolio 3. Very easy. Normally it's correct. Yes. Let's have the next one also. Now I am looking for the third portfolio. Correct. Rohan has given the answer correct. Yes. Just get the portfolio return also. Portfolio return. Yes, 34%. Yes. Chaitani, return is correct. Ramyalini, that is correct. So, yeah, risk is 3.98. Then I will put the values there. 3.98. Right. Now we have been able to prepare a schedule on risk and return for a portfolio. There are 3 portfolios with different risk return profiles, and we will go to the lesson again. Now, instead of covariance, if you do not have covariance value, but we have sigma and sigma values, then without going into covariance, if you have the correlation coefficient, you are in a position to calculate this. Right. Now we will see how we can go for more than one asset. Sorry, more than 2 assets. Now here it is given for 3 assets. Now you can look at the format of the formula. Just look at the first 3 terms. The first term is W1 squared sigma 1 squared. Now this is in the case of a 3 asset portfolio. Now here there are 3 assets. Now we have already done for 2 assets, and this is the 3 asset case. W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus W3 squared sigma 3 squared plus, so then now there are 3 square terms, then plus you will have another 3 terms which you have to relate with each pair of assets. Now when you have 3 assets, you will get 3 pairs. When you have 3 assets, you will have 3 pairs. So rather you can put it as an example, ABC. If the assets are ABC, you can have a pair A and B, another pair B and C, another pair A and C. Those are the pairs which you can prepare or which you can put. So if you have 3 assets, you will have 3 pairs of assets. So therefore you need to have 3 covariance values. 3 covariance values. Covariance A and B, covariance B and C, and covariance A and C. These are the covariance values which we need for a 3 asset portfolio. If you have 4 assets, what is the situation? Then how many pairs would be there? So likewise, you have to go for that. So if you have 4 assets, you will have A, B, C, D. So therefore, you have A, B, B, C, C, D. A, B, B, C, C, D, there are 3. Then you have A, C. Then yeah. So there's a particular trend or routine where you can go through to select or to find out the possible pairs. Possible pairs. I will just show it on the board. Because when you have even any number of assets, all assets will have couples with each. So therefore, you have to identify the couples. I will show it. I think that's it is necessary for right. When you have three assets, it comes like this: 1, 2, 3. So you have 1, 2, you have 2, 3, you have 1, 3. Then in a three asset case, you will have three pairs. And when you have four assets, we will see 1, 2, 2, 3, 3, 4, then 1, 4, 1, 3. Two fours. Now all together, all have been taken. 1, 2, 2, 3, 3, 4, 1, 4, 1, 3, 2, 4. Right. There are 6 here. Now I think you can see when you have 4 assets, there will be 6 pairs. There will be 6 pairs. Now this is a matter of finding out the number of pairs. So when you have more than 2 assets, then you have to apply these principles to arrive at the formula. So in the case of 3 assets, you will have a formula like this. W1, say, if you take the assets as 1, 2, and 3, weights as W1, W2, and W3, risk as sigma 1, sigma 2, and sigma 3, then correlation coefficient as, or covariance as covariance 1, 2, covariance 2, 3, covariance 1, 3. Those are the 3 pairs. So then how are we going to put the formula? The formula is equal to sigma p squared is equal to W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus W3 squared sigma 3 squared plus 2 W1 W2 covariance 1, 2 plus 2 W1 W3 covariance 1, 3 plus 2 W2 W3 covariance 2, 3. So this is the formula for the 3 asset portfolio risk. I think is that okay? If you don't get it, just let me know. And for the 4 asset case also, you can prepare a formula. Likewise, for any number of assets, you should be in a position to prepare that formula. Is that okay? Now just I am asking, now have you found the trend, or have you found the particular methodology of forming a formula or preparing a formula for a particular number of assets? I did it for you. I did it for 2 assets, and I just now told you about 3 asset situation. And 4 asset situation also, you should be in a position to come up with the formula. What do you say? Because it's not that it's very rarely if you get a asset portfolio with more than 3 assets in your examination. It's not that frequent to have such questions, but you need to expect a question where you have 3 assets in a portfolio. That can be a frequent type of a question, but you have not got questions. It's very rarely you get a question if you have more than 3 assets in a portfolio, but you should be in a position to devise the formula for even 10 assets. So then you need to see how you can do it. I can give you the way. So that's what I just explained you, how you can get the pairs into the equation. Now I just put 1, 2, 3 for 3 assets in, and there you get 3 pairs, 1, 2, 2, 3, and 1, 3. Those are the 3 pairs in 3 asset portfolio. And if you have 4 assets, you will have 6 pairs. 1, 2, 3, 4. There you get 1, 2, then 1, 3, and 1, 4. Then I have just put those things on the board. There you get 1, 2, 2, 3, 3, 4, 1, 4, 1, 3, and 2, 4. Those are the possible pairs in a 4 asset situation. Even if you take 5 assets, you will be in a position to get those things into the formula. Right. Any questions on this? What I want to do is, I want to just tell you, or just teach you how to go into a formula where you have many number of assets. That is my intention. So I don't know whether you got my point. If you have got it, then we can just proceed. Now you just look at it with 3 assets. Rather than put in covariance, they put sigma and rho. Right. Now we go to the example. Mr. Asoka has a portfolio of 4 common stocks with the following market values and returns. There only the returns are given. Market values are also given. And the weights. These weights actually we can arrive at. Even they are not been given, so we can just arrive at the weights because you have the market values and the totals. So this is 10,000 out of 100,000, say it is 1.1%. 20,000 out of 100,000, that is 2% or 0.2. 30,000 out of 100,000, that is 0.3. 40,000 out of 100,000, that is 0.4. Right. Returns are given. So portfolio return is given. It's so easy. 10% into 0.1, 14 into 0.2, 16 into 0.3, and 15 into 0.4. That is that comes to 14.6. The second example, 2 assets J and K have the following risk and return characteristics. Expected value of J is 18%. Sigma J is 25%. Rho JK, that is the correlation coefficient, is minus 0.2. And expected value of K is 14%. Sigma K is 20%. Portfolio A and B portfolio has a weight of 50% in J and 50% of K, and portfolio B 40% of J and 60% of K. Now the exercise is given here. Return of portfolio is given as this, and return of portfolio B is given as this. And the risk is also been calculated. Right. Now, after getting the portfolio A's and portfolio B's risk and return, so you have this schedule where portfolio A's risk is 14.361%, return is 16%. Portfolio B's risk is 14% and return is 15.6. Now you can just see with different weights of asset J and K, the portfolio risk and return also will give different values. Or in other words, when the weights are being changed, you will get portfolios with different risk return characteristics. Now I want to just show you something here. Say, if you have 2 assets or 3 assets or whatever, by changing the mix or changing the weights of each in the portfolio, you can come up with different portfolios with different risk and return characteristics. So how many of portfolios you can come up with? Give me an answer. When you have 2 assets, you can mix these 2 assets in different weights. 20, 80, 30, 70, 40, 60, 50, 50. Likewise, you can change the weights. By changing the weights, you will get a different portfolio with different risk return characteristics. How many portfolios you can make by mixing the 2 portfolios or two assets? Yes, give me an answer. Give me an answer for that. Suru's answer, no, more than that. More than that. How many portfolios you can get? No, I am asking you the possibility of getting a number of portfolios, because I just showed you particular examples where I had 20/80, 30/70 and 40/60. There are only 3 we got. I am asking the portfolios, right? I am not asking the pairs. So I ask the portfolios which you can make by having different weights. That's a simple question. I mean, just think little further, then you will get the answer. How many portfolios you can make by mixing A and B with the way you want? I mean, you can have different weights. How many of such type of portfolios you can make? Champika says it is 200. Karunananda says it is 100. 2. No. Yeah. Chaitani's answer is correct. Huh? Yes, uncountable or infinite. Yes, infinite. It is infinite. Why you say infinite? Say, I will say, I have 10% and 90%, 1% and 99%. Likewise, you have several. There's no end to that. It is infinite. Because why do you say infinite? It is not the number only. Say, I think some people have said it is 200 or 100. So they only go by the digits or integers. But you can have this way also. Yes, what is the problem, Sanjeev? Yes, Sanjeev. Yes. What's the problem, Sanjeev? Okay. Now say you can have 10.1% in one asset, the other one would be 89.9. So likewise, you can have so much of alternative weights. So that would come to infinity. That is how it comes. Okay. Right. Now we will go to the lesson again. Now our schedule goes to another thing, because now we will try to plot these all risk return figures into a graph. When you plot that, the two axes, the one axis depicts the risk, the other one depicts the expected return. Now the horizontal axis depicts the risk and vertical axis depicts the expected return. Or in other words, x-axis depicts the risk and y-axis depicts the expected return. Now you just see this diagram. The total risk is given along the x-axis or horizontal axis, and the expected return is given along the vertical axis or the y-axis. Now, for example, now if you have a number in here or some values here, so you will be in a position to plot these different portfolios according to their risk and return characteristics. Now, for example, if you take this E, the point E here, so that is the, what is the risk of that E, portfolio E? This value is the risk. What is the return of that? The return is this much is the return. So return depicts the y-axis, risk depicts the x-axis. So the x coordinate, the risk is given by x coordinate, return is given by y coordinate. Okay. Now this plotting was done by taking different portfolios with different risk return characteristics. Now, if you look at the board where you see the three portfolios. The return is in the y-axis. So this is y, this is x. Right. Now I will try to put a graph. Here. expected return. Risk or the sigma. Right. Now you can calibrate this value axis. Now you have the values here. Returns are in the range of 32, 34 and all. So we can see this way. 10, 10, 20, 30, 40. Right? So for the risk axis or the x-axis, you have 3 point something. So you can have values like this. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. So I'm just putting it that way. Now, how are we going to plot these things? Here, 3.258, 32, 3.258. So it is somewhere here, 3.258. And what is the corresponding return? 32. So it's like this. This is portfolio 1. Portfolio 1, right? Then you take another one, 3.729, 33, 3.729. 3.7 comes here, somewhere here. And this 33. 33 is somewhere here. Right? That is portfolio 2. Then portfolio 3, 3.98 is almost 4. And the value is 34. Right. Now this is the, if you connect these points, you get this type of a curve. Now likewise, if you take the lesson, there you have this. But instead of, in addition to these points, you might get these points also, because you can have infinite number of portfolios by changing the weights of the constituent assets. Right. Now, if you get this type of a plot or number of points on the graph, now, if you just connect the values or connect the points which were appearing as a frontage, and we call it a frontier. Frontier means now this is like a, now yeah, you don't find any points beyond this point. So to the left of this curve, you don't find any points. But if you find any points, that those points are found to the right of the curve, to the right of the curve. So if you can demarcate such a frontier, we call that frontier the efficient frontier. Why it is so? Now just look at the point on the frontier. I don't know whether this pointing is okay. You can see this pointing. Can you see the red point on the curve? What do you say? You see the point on the curve? Red point? You can't see? Can you see the pointer on the screen?
No, sir.
No, sir, we cannot see.
No, you can't see. No? Anyway, it's okay. So I will again go to the lesson. Okay. Now just see. Now all these points are possible, but after putting these points, what we need to do is we can connect all the points which appears as the frontier. And such curve is called the efficient frontier of the portfolios. And why we call it efficient? Now just look at this. You can see the cross here, no? This is the one, the cross. And if you take a point just below that, this one, it is just below that point. Now can you see the cross mark?
Yes, sir.
Yes. Now I put the cross mark on the point which lies on the frontier, right? So if you take that point into consideration, what is the risk of that particular portfolio? That value is given by this length. This is the value of risk for this point, right? And this is the return for this point. But if you take another point just below that point, so I just now demarcate another point which you can see the cross, that is right down, no, right below this point. So what you see, you have the same risk, right? Same risk, but the return is less than this one's return. So the meaning is, if you have a point on the frontier which represents the portfolio's risk and return, so that point gives a higher return for the same risk. Now if you take this point, the risk is same but the return is lower. So then we consider this point as an efficient point. If you take another point on the efficient frontier, that is also the same. So if you take a point right below this, that point has the same risk, but it has a lower return. So therefore, this curve contains all the portfolios where it has a highest return for the same risk. So that means this portfolio or this particular curve is called the efficient frontier, because all the portfolios represented on the curve are efficient portfolios. That is why we call this curve the efficient frontier. Because now earlier we went into devise several portfolios with varying the weights, and we realized that we can prepare or we can have infinite number of portfolios by changing the weights, and we will be in a position to have risk and return values for those things, and those points can be plotted on the graph. But since this is an example, I have taken only a small number of points, 1, 2, 3, 4, 5, about 11 points are here. Yeah, 11 points. Only 11 points are here, but it is not 11. You can have infinite number of points by having different weights for these two assets, and the plotted graph would be very much congested than this, but I have just only taken 11 points here. Out of these 11 points, I have taken 5 points only, and those 5 points lie on the efficient frontier. Now, I think you got the meaning why we call it efficient frontier, because if you take any point on the frontier and another point below that, right below that, and that gives a return less than that, but with the same risk. So then what is our selection then? We have to select the particular point where you get the highest return for the same risk, highest return. So that is what we call the efficient portfolio. If you take any point on the frontier, that represents an efficient portfolio. Right. So that is why we call this particular curve the efficient frontier. Now this curvature, what is the meaning of curvature? Now you might have a curve like this, or that curve can be more convex, or I will show you what it is. Now this is the way curve we are referring to. This can be like this. So this is the one type of a curve which we can have by using the different portfolios with their risk and return characteristics. And it can be like this also. It can be like this also. Now that all depends on the correlation between these two assets. Correlation between these two assets will decide the shape of the curve. The shape of the curve would have been decided by the correlation between the two assets. Right. So this is what you call the efficient frontier. Efficient frontier. Now we will see how are we going to form an optimum portfolio. Now there you have to refer yourself to the Markowitz portfolio theory. I suggest if you can read something on Markowitz theory in books or any other internet resource or whatever it is. So that is a recommendation I am giving for you. If possible, you can go to the internet and you can just go to Google and search about Markowitz portfolio theory, and you will get several articles on that. And just read it, and then you get a better understanding, and you can check whether what I have said here is correct. So that is the way you need to learn. Then just look at it. Under the Markowitz portfolio, the following assumptions are taken into consideration. Right. Now, any investor likes to maximize the expected utility of his total wealth. That is very rational. I mean, people really behave in that manner. So that is Markowitz theory says. All investors have the same expected single period investment horizon. Now those are the assumptions coming under Markowitz portfolio theory. So what is one assumption number one is all investors, they seek to maximize their utility. And the second one is all the investors have a expected single period investment horizon. So what is the meaning of investment horizon? Because you expect your assets to give you returns during a particular period of time. Say, for example, most of the investors are having a 1 year horizon for their investments. But that doesn't mean all are having the same investment horizon. But in this particular Markowitz theory, it assumes that all investors have a same expected period, investment horizon period. Or investment horizon is single, one same. And investors are all risk averse. What do you mean by risk averse? Risk averse means they try their best to avoid risk. That doesn't mean that they always try to have a zero risk, but they try to have a minimum risk. That is what you mean by averse, risk averse. They always think about the risk. They just want to minimize or get rid of that. Risk averse means that, but they know they are not in a position to get rid of risk 100%, but they will try their best to minimize it. Investors base their investment decisions on the expected return and standard deviation of returns from a possible investment. So that is another assumption, because investors decide on their investments on the basis of expected return and the risk. Then perfect markets are assumed. So what do you mean by a perfect? Those are all assumptions, right? Now in the question, sometime there can be a question asking what are the types of assumptions on Markowitz portfolio theory, so that there can be a multiple choice question or something like that. So that is why you need to understand these things. Now, perfect markets are assumed. So that is another assumption. What do you mean by a perfect market? For a perfect market, there's no transaction cost at all. And everyone in the market knows about the prices. There's no price differentiation or whatever, and no taxes at all. So such markets are called perfect markets. Given the above assumptions, an investor will want to hold a portfolio somewhere along the efficient frontier. So now they need to maximize their expected utility. No. So in order to maximize their utility, what they try to do is they try to have their portfolios on the efficient frontier. The exact location depends on the investor's risk return preferences. Depending on the risk averseness, investor needs higher compensation for assuming risk. Then the selection will be optimal when it is made wherever on the frontier itself. Right. Now it is like this. On the frontier, there are different places you can point out, but in different places you get different risk return characteristics. So I will just go again into the frontier and explain. Right. Now here, you have a particular value for risk. This is the risk value. Here, this length is the risk value. Now I am just moving my cross from this point to this way, and now it meets expected return axis, and this is the distance. This distance represents the risk of this particular portfolio. Then what is the return of that particular portfolio? The distance. Now I just have this cross here, and I move that cross down, and when it meets x-axis, the distance it traveled is the expected return value. Right. Now if the particular person investor satisfied with this particular risk and return characteristics, he should go into this particular portfolio. That is his selection. That is his optimum selection. Now he likes to have a return of this much with this much of a risk. Right? So that is his risk averseness. But another person might satisfy with a lower risk and a lower return also. So this can be another person's optimum selection. So likewise, person to person, the optimum selection would be changed. Right, now we go into another theory called capital market theory. Now, there also you have a set of assumptions. Assumptions underlying capital market theory are as follows. Investors are capable to attain the investments on efficient frontier. So, another assumption here. So, investors, we assume that under the capital market theory, we assume that investors are capable. So, they have the capacity to attain investments on efficient frontier. Money can be borrowed and lent at the risk-free interest rate. So this is, in reality, it won't happen. But as an assumption, we have to just come into this assumption, that is, money can be borrowed and lent at the risk-free interest rate, denoted R, stated differently as VAR or variance of R is 0. That's what I told. Because if your return doesn't change, or doesn't vary, so then it is 0. Then it is, we call it is a risk-free investment, if that is the case. Investors have homogeneous expectations. What do you mean by that? Homogeneous means, now expectations. Now homogeneous means it's similar like. That is what you mean by that. All investors have a set of expectations which are similar with each other. No taxes or transaction cost exist, no inflation exists, capital markets are in equilibrium. It is in market equilibrium. So what do you mean by market equilibrium? Because for a given supply, the demand is decided. That is what you mean by equilibrium, and the price is determined. And equilibrium prices are available on the market. Now, if you have this type of a market, capital market, and we introduce a risk-free asset into the above-mentioned portfolios with the said assumptions, the efficient frontier would change, right? Now here we talk about different portfolios, and this is the efficient frontier. If you really include, now all these portfolios, all assets are risky assets. But if you want to introduce or include another set of assets which are risk-free into this, as a result, the efficient frontier would change. That is what the capital market theory says. Yeah. When we introduce a risk-free asset into the above-mentioned portfolios with the said assumptions, the efficient frontier is changed from a curve to a straight line. This new efficient frontier is called capital market line. Now, actually, this is a phenomenon explained through this theory. Now, basically, right, you just think about your bank or your organization where you have several investments. Now, you might have company stocks portfolio. You might have government bonds portfolio. You might have a treasury bill portfolio, whatever it is. But if you can have a mixed type of investment where you have risky assets, basically the risky assets are the company shares, together with risk-free assets also. Now, when you have different portfolios in risky assets, there you have a efficient frontier, as we now discussed. But if you enter or if you include some risk-free assets into those portfolios, then the new portfolios will have risk-free part also. Not only the risky assets, you have risk-free assets also there. And that will change the efficient frontier. Now, earlier with all risky assets, efficient frontier was a curve. But if you include risk-free assets into the set of portfolios, there will be a change in the efficient frontier. And the efficient frontier would become a straight line with a certain given characteristics. That line is known as capital market line. Capital market line. Now, this is not a miracle or whatever. In reality, this type of things can happen in organizations, because if you are risk averse, all these bankers, basically, they are highly risk averse because they follow all these prudential principles, or prudent. They want to call themselves prudential bankers. What do you mean by prudent? Prudent means they try their best to have a optimum risk-return trade-off. So that means they don't like to take so much of risk. In order to bring down their risk levels, what they do is they insert or they include risk-free assets into their risky asset portfolios. That's a normal phenomenon in organizations, basically the banking organizations. The reason behind that is bankers are in nature, they call themselves prudent bankers. The prudency means you won't go for unwanted or unlimited type of risk. You have to be very careful about it. In prudential norms or whatever, what you do is you try your best to have a better risk-return trade-off. Or in other words, you need to get the highest return from minimum risk. That is the intention of a banker or a prudential investor. So what they do is even though they invest in risky assets like company shares and all, or debentures, they try to bring down the risk of those portfolios by adding risk-free assets into that portfolio. And when you add risk-free assets into the portfolio, what would happen? The efficient frontier of the portfolios would be changed, and that would become a straight line. That line is known as capital market line. Right now we will see how this capital market line, how we can depict that capital market line on the graph. Now, these measurements you need to look at, and you have to be careful about it. Now I have just shown here the efficient frontier, early efficient frontier. But when you add risk-free assets into these portfolios, what will happen is the efficient frontier will change and it will become a straight line. Now this is the straight line. That straight line, what happens is it starts from y-axis and the value there would be R. R is the risk-free return, risk-free rate or risk-free return. From that point, the capital market line goes like this and it becomes a tangent to the efficient frontier. You know what is a tangent? It doesn't intersect the curve, but it touches the curve on one point. So such type of a line is called a tangent. A tangent. Now, this CML, ECML, capital market line, you can see that straight line. That straight line starts from R. It starts from R. And this is the capital market line. And this is the new efficient frontier after adding the risk-free assets into the portfolio. Before adding the risk-free assets, you have this efficient frontier. And this portfolio, on this particular point, the capital market line touches the efficient frontier. And this portfolio is known as the market portfolio. And there, the risk is sigma m, return is ERM. You can just see that. Right. Now, this is the capital market line. It touches the efficient frontier at the market portfolio. Now we will go into more details. If you take this line into consideration, it has two parts. Now this is M. Now M is a point in the middle of a CML or whatever, but we can't say in the middle, but CML can go infinitely over here. There's no limitation. It can go over there, so it goes to infinity. But when you take this, you can demarcate this line into two parts. Now, the line which is to the left of this point, which we call the lending portfolios. And there's another part which is to the right of M. That particular part is called leverage portfolio. We will see why we call it that way. To the left of the M, investors on the CML will hold both the risk-free asset and the risky portfolio. So the people who invest in both risk-free and risky assets will have their efficient frontiers on this. So therefore, we call it lending portfolios. But if you have a just the opposite is the true to the right of the M. In this case, investors are borrowing at R and investing more in M. They are utilizing leverage. Now, this is a point where you need to understand better. Of course, what happens is people or the banks or whatever, what they do is they invest in risky assets and risk-free assets, both. But there are occasions where an investor can borrow something, and that borrowings also the person can invest in some other risky assets. So what is that? So it's like this. A borrowing is taken as minus investment. Minus investment. Now I will show it on the board, right? Now, when I put this graph this way, this is risk, this is expected return, and when you have the efficient frontier like this, now this is what you call the efficient frontier, EF, and I will show you the capital market line. This is M, this is R. Right? Now if I just point this one onto the graph, can you see that? Can you see that?
Yes, sir.
Oh,
Yes, sir.
right. Anyway, now this is the efficient frontier. Now this efficient frontier is formed with risky assets. But when you add risk-free assets into the portfolios, what will happen is the efficient frontier being changed to a straight line. This is the straight line which I referred to. Now that straight line starts from the y-axis, and what is the place? This is the risk-free rate. The value is the risk-free rate here. So we put it as R. And it touches the efficient frontier at M. And this is what you call the market portfolio. Now, from this point, the line divides into two. So the line to the left of M is called lending portfolio. Lending portfolio. This is lending. And the other one, the line which is right to the M. Now, it's like this. Now, this pointer goes along the line, and you see that there's no limit to this line. It can go to the infinity, right? So this particular part is called the leveraged portfolio. Leveraged. Now, what is the meaning of lending and leveraged? Now, there are two types of portfolios, asset portfolios. One portfolio is constructed with risky assets, and we call it market portfolio. And another Other types of portfolios are constructed with risk-free assets. Risk-free assets. Now, what happens is, as under the capital market theory, we can say the borrowing and lending both can be done at the risk-free rate. So the risk-free assets can be borrowed or lent at R. Right? So what the people can do? They can, the people in the sense the investors, even in this particular case, it is the institutions, the banks, they can invest on risky assets. For example, we say the banks can invest in risky assets and have a return of ERM. ERM. And that is the return given by the risky assets. What is the return given by the risk-free assets? R. Capital R. This is the notation, right? It's a standard notation for a risk-free rate. And there are only two types of assets. One type is risky, the other type is risk-free. Now in the portfolio, we can say risk-free portion is, we can say XR. XR. Risk-free portion. Risk-free weight of portion is XR. Risky portion that is we call XM. XM. Now you can come up with the portfolio return value, equation for a portfolio return. So portfolio return, we can say RP. RP is equal to XR into R plus XM into ERM. Now you can just see the RP, that is the portfolio return. This portfolio, I am referring to the portfolio which contains risky assets and risk-free assets both. From the risky assets, the return is ERM, and we have a weight of risky assets XM. So therefore, what is the return? XM into ERM plus the risk-free return is R, risk-free weight is XR. Then the return comes from that is XR into R. Then the total return of the portfolio which contains risky and risk-free assets is XR into R plus XM into ERM. I think, is it making sense? What do you say? Now I am referring to the portfolios which we made using risky assets and risk-free assets. So it's like this. You can have 20% of risky assets and 80% of risk-free assets, or you can have 80% of risk-free assets and 20% of risky assets, whatever the way. Right? Now, all such portfolios will have a efficient frontier to the left of M. Now I am asking a situation where in a portfolio, if you have risky assets, 150%, would it be a possibility? Your investment in risky assets will be 150%. Would it be possible? I am asking you yes or no, right? You just tell me, is it possible?
No.
You say no. Yes. Any other answers? Any other answers? Now what I am telling is, now you are a person who want to invest both in risky assets and risk-free assets. A person tells that he would invest 150% in risky assets. I am asking you, would it be a possibility? One person says it is no, but anyway, any other answers for that? Now I told you borrowing can also be considered as a minus investment. We don't call borrowing an investment, but borrowing is a minus investment. It's like, you know, when you talk in terms of loss, we call it a minus profit, is it? In the same manner, borrowing can be considered as a minus investment. With that concept, are you in a position to put some rationale into that? Yes. What I am asking is, say, a person can say, I have invested 150% in risk-free assets and I borrowed 50% risk-free assets. Now the equation is balanced, is it? 150 minus 50 becomes 100. Because your ultimate condition is W1 plus W2 should be 100% or 1. That's happened. Okay, so therefore you can't say no. There's a possibility. What is the possibility? Now, if you invested 150% in risk-free, risky assets, then you borrowed 50% of risk-free assets. So the equation comes as 150% minus 50%. That comes to 100%. Yes. Yes, it's true. Now you see, you can't say no. The possibility is there. What is the possibility? Because you are not going to invest the whole thing. You invest more than 100% in one, but the particular difference you have to borrow. So such portfolios are depicted to the right of the point M. So those are called leverage portfolios. So otherwise we can have this way. A person can say, I invested 60% in risky assets and 40% in risk-free assets. It is a normal portfolio. It's a normal lending, no normal investing portfolio. But if one says that, as our example said, say another person can say, I invested 200% in risky assets and borrowed 100% risk-free assets. That also a possibility. 200 minus 100 is again 100. Yeah, any question? Yes. Okay. Now we have been discussing about the leverage portfolios and lending portfolios. The leverage portfolios are where you had a borrowing and you borrowed and invested. That is what it means. So such portfolios are called leverage portfolios. So that is depicted to the left of M in the capital market line. So sorry, to the right of the M in the capital market line. The lending portfolios are depicted to the right of to the left of the M in the capital market line. So that is how the capital market line is constituted. Right. Anyway, I think we may we may not have time to go further. Almost 12:35. Anyway, any questions? Any type of a clarification or whatever? Then we will be in a position to just sort it out in another 2-3 minutes time. Yes. If you have anything, let me know. Are you in a position to say work out the exercises, supplementary problems? I think so, because there's no big thing here. You try your best to on your own you do these things. Right. Then anything you need to clarify? Right. So then I will wind up today, and we will have the sessions on next week. And in the meantime, you will have to go through these supplementary problems and then do it yourself. And if you find any type of confusion or any type of difficulty, then you can come up with your difficulties and we can discuss those things on. And that could be the way you need to follow, because otherwise what happens is you just be a passive listener and you won't gain anything. And it's a matter of, wasting time. So therefore what I want you to do is you just lively engage in these things and you do things yourself. And if you don't understand something, then you clarify that, and then again you can just go into your own work. That is how you need to do it. And just try your best to apply those things in your day-to-day work if possible. So that is the best way to learn things. Right. With that, I just wind up today, and thank you very much for all of you who really engage lively in the discussions. Thank you very much.
Thank you, sir.